All right, sir.
Right.
Okay, good afternoon all. Good afternoon, Prof. Good afternoon, doctors. Good afternoon, my co-researchers. My name is Abdulaziz Kabir. I'm here to present the topic, spiral optimization algorithm based on deep learning approach for skin cancer classification. Next slide. Next slide. Okay. Early detection is critical for effective treatment of skin cancer treatment. And in this research, we try to look at how to develop a spiral optimization algorithm to solve the problem of early detection of skin cancer detection. Skin cancer is one of the most prevalent forms of cancer worldwide, requiring urgent diagnostic attention. Traditional method rely on manual examination, which is often subjective and prone to human error. So deep learning approaches show promise in improving accuracy and efficiency in medical image classification. Early detection significantly increase the chances of successful clinical outcomes and patient survival. Next slide. Next slide. Okay. Spiral optimization algorithm, it mimics natural dynamics. The study introduced a novel spiral optimization algorithm specifically designed for hyperparameter tuning. Also, by effectively avoiding local minima, SOA provide a robust framework for complex medical image analysis. Next slide. Okay. Now, integrating the SOA with a convolutional neural network, it enhances diagnostic precision. And if you look at the image here that we display, you can see the image of the skin, you can see the convolutional neural network, which is being supported by the SOA, the spiral optimization algorithm. And in this case, when our input is, when the input of the image is being put into this model, at the end of the day, we have the diagnostic result. Next slide. Okay. Now, after getting this model, we need to test what we've achieved. So experimentally, we validated our research with the public available data set, which is the ISIC archive data set. We also use the HAM 10,000 data set, human against machine 10,000 data set of skin cancer. We achieve the following. We compare it with the performance metrics of accuracy, sensitivity, and specificity. Next slide. Next slide. Okay. When we optimize our CNN, achieve superior classification accuracy. So from the bar chart, you can see that using the SOA, which is our proposed algorithm, we achieve a more better result than using the grid search, random search. So next slide, please. Next slide. Next slide. Okay. Also, the same thing here, we can see that the SOA provides a scalable solution for automated medical analysis. So instead of our medical doctors, anybody that have a skin cancer issue, if you have this model on your computer, it's just for you to input the image on the computer and it will diagnose and tell you whether this is benign or not benign type of what? Skin cancer. Next slide. Okay. Thank you for listening. Thank you for listening. Thank you.
No, so, Mr. Abdulaziz, thank you for your presentation. So it's time for question and answer. So,
Okay,
do you
sir.
have question for you? Signify. Questions, comments, observations, either of them or all are accepted. Okay. Number 1, number 2, number 3, number 4. So for the online participants, in case you have questions, please you can type your question on the chat box. Thank you.
Okay, sir.
Good afternoon, Mr. Abdulaziz. Can you hear me,
Good
sir?
afternoon. Yes, I can hear you
Yes, sir.
very well,
Thank you
sir.
very much for the presentation. So
Thank you,
I
sir.
I just have some concern with the work. You mentioned that you used grid search and random search as a model, right?
Okay, sir, I'm listening.
Yeah, you said you use grid search and random search as a model for the work. So I'm asking
Yes,
because you mentioned earlier that SOA, that is the spiral optimization algorithm, you said it is for
yes,
hyperparameter tuning,
yes,
right?
sir. Yes,
But
sir.
so which we know that grid search and random search are also used for the same purpose. Do you know that,
Yes,
sir?
sir. Yes, sir.
So
I
now
know,
my
sir.
question is that which model was actually used for the work? Like which model did you use for the work? Because we are trying to recommend that SOA is a better tool for hyperparameter tuning, right?
Yes. Okay. For
So
the work,
my question is that, yeah, yes, sir. You want to say
okay.
something?
Yes,
So the question is that,
I'm listening.
can
Go
I
ahead.
continue?
Yeah, you can continue.
So my question now is that, which model did you use and which model do you use for work?
Okay, sir. Can you hear me?
Yes, I can hear you, sir.
Okay, sir. We use SOA for the work. So after we finish using SOA for the work, then we now go back and see, according to literatures, we've seen what grid search have done. Then we try to compare our work with the work of the grid search algorithm. Then we see that our work is far, far better than using the grid search algorithm.
But grid search is used for hyperparameter tuning with random search.
Yes.
Yes. So now, okay? What you are saying now is that you use grid search as a model for the work.
Yeah.
You use it
Yes,
as an
sir.
algorithm for sir.
Yes, sir. We use grid search. We use grid search for the model. After we finish using grid search to fine-tune the hyperparameters, we now compare the performance of the grid search and that of the SOA. And we concluded that SOA is far better than grid search, sir.
Mr. Abdulaziz, read the first paragraph of this, the first statement of this thing on the screen. It says the study introduces a novel spiral optimization algorithm specifically designed for hyperparameter tuning. That's what you are trying to say now is that you want to recommend SOA as a tool for hyperparameter tuning. But for your hyperparameters now that you've gotten for which model and which model, do you understand what I'm trying to explain? Because they are trying to say you are using hyperparameters, they are trying to get the optimal parameters for a particular model. So which algorithm did you use for the work eventually? You are working on skin cancer, right? So image classification.
Yes,
so which deep learning model did you use? That is what I'm trying to ask.
okay. I thought maybe, okay, I understand your question.
Okay, please respond to the question.
Okay. The deep learning techniques I use, I think I can't, is there in the write-up under the abstract? So I can't
I
remember
think
it precisely.
it's really good. Just speak to the work. This is your work. We are interested in it. You can't just go to hyperparameter tuning without having a model to work with. So using spiral optimization algorithm for hyperparameter tuning is not bad. And if you find it useful, fine. But then you want to know which model
Okay.
have you used.
If you recommend for the code, I can also send it to you as a zip file.
No. We are not requesting for the code. We are interested in the model that you used. The model. What model did you use? Tuning a parameters or set of parameters is not the issue. Which model? Okay. It's okay if you don't want to answer that. But I think you should know that people will also doing this in the house, so they will be interested in what what you are doing, and the essence of conference is so that we get what you are doing properly. So you have convolutional neural network, and I believe you just speak to it directly rather than refer us to this one. Okay, so let's go to the next one.
Actually, sir, can I come in there? Hello, sir. Hello, sir.
Next question. It's okay. We just take the next question because of our time. There's no time. We have 5 minutes to leave this place. All right, let's
Okay,
have
sir.
Are you hearing me, Mr.
Yes, I can hear you. I can hear you.
I want you to go, with that interface, go to the slide where you actually compare the random search against the grid and the SOA.
Sorry, come again. I can't hear you, sir.
No, I'm talking to you that thing at the moment.
Okay.
Let's compare random section.
Okay, from this chart here, said
Yes.
you are proposing the SOA for your model against the skin cancer classification. So I want to say that you didn't actually show us your performance metrics. What was the accuracy for the grid search, the random search, and the SOA? Or maybe you used other performance metrics like F1 score, sensitivity, and others. You didn't tell us the percentage of how good the model was.
Okay, I have it documented. Okay, continue. I'm listening.
And secondly, the data set you used, you didn't tell us the shape of the data set. You let us know what are the number of patients that are available in the data sets. What kind of data and variables? Is it a clinical data? Do you consider lifestyle factors with imaging data into this? That's my question. Thank you.
Okay, can I answer your question now? Hello? Can you hear me? Hello? 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 Hello, can you hear me? Hello?
Are you there?
Yes, I'm there. Okay, the question is asking about the data set. That's the question 2. I told you earlier on that I use the HAM 10,000 data set. The meaning of HAM is human against machine data set, which comprises of 10,000 images of skin cancer. So after we use this image to train our model, we now use the clinical data set, the ISIC data set, to test the authenticity, the accuracy of this model. So, and the first question that you asked that I did not tell you guys about degree search, everything is documented. If you want it, I can send it via the WhatsApp platform to you so that you can see. Thank you.
Okay, yeah, I think, I don't know if I want to allow more questions because of our time. We are having just 2 minutes and we have to end. Okay, but Mr. Abdulaziz, we are grateful for your presentation. Maybe next time it will be good you have a kind of physical presentation so that we can really look at what you are doing, and then people who are really interested, they want to see what you are doing and make it better. So I want to believe that the essence of a conference is to present your work, and then people criticize it constructively and make it better for future use. And that's why we are here. So people will ask questions, we'll left and right, so that we'll be able to get to the real deal, right? And but then we have been able to come to this far, so we can't take any question again. I'm sorry for those ones that signify was not get to ask our question. We have to end today. So tomorrow, by God's grace, we are going to be starting by 9 a.m.